Okay, this video is going to take us through the chain rule tree map. So on your screen, you see a list of functions in column A and a list of functions in column B. So the functions in column A, they are solely functions of x. For example, sine x. The input to that function is just an x. Go down to the third one, ln x. The input of that function is solely an x. On column B, these are functions of x, but sine, if you look at that first one, sine is a function of 2x plus 7. We've inserted another function into the argument in place of just an x. Likewise, go down to the third one. There's a function of 2x plus 1 that's inside the power of 3. So these are all composite functions where we have a function inside a function. So this first list of functions, you know the derivative of all 6 of these. However, the ones on the right, since we have a function inside a function, we have to learn a new rule called the chain rule in order to differentiate those. So the way to recognize if a function requires chain rule is you're looking for a function inside a function. So you're going to find your tree map, and then you're going to sort these functions as needing chain rule or not needing chain rule. So I'll go ahead and why don't you pause your video and sort these. The ones who have an input of just x, like sine x, that would go on the right-hand side of the tree map where chain rule is not needed. The ones who have an input, which are something other than just a plain old x, those would go on the left side. We would need chain rule for that one. Okay, so go ahead and pause the video and sort those appropriately. Okay, so hopefully you sorted on the right-hand column sine x, cosecant of x, and x times sine x. All 3 of those circled functions do not need chain rule. We do need a special rule for this last one. We would need product rule for that one, but we don't need a special rule for the others. So those do not need chain rule. Let's go ahead and find the derivative of these 3 that do require chain rule. So next to the ones on the left-hand column, let's go ahead and differentiate. I'm not going to do that for the ones on the right-hand side because you already know how to take the derivative of those. So the derivative of sine of 4x. When we apply chain rule, we first take the derivative of the outer function. So the derivative of sine, as you know, is cosine. The inside function remains unchanged, so that would remain a 4x. Now we move inside and take the derivative of the inner function. The derivative of 4x is 4, so we multiply times 4. The next one you should have on your list is cosine of x over 6. So when we differentiate that, we're going to take the derivative of the outer function first. The derivative of cosine is negative sine. The inside function does not change, so we leave that x over 6 unchanged. But then we have to go back and differentiate the inner function, and the derivative of x over 6 is 1/6. So certainly you could rewrite this and move that 1/6 to the front after the negative sign, but it's not necessary. And then we have cosecant of 3x. Differentiating cosecant, we get negative cosecant cotangent. The argument does not change, so we leave that 3x inside. So we took the derivative of cosecant, and now we move inside and take the derivative of the 3x. So all of that times 3. Okay, so you should have had, you should have the circled functions written on the right, and these 3, of course, are written on the left. So go ahead and sort these. 2 of them will require chain rule, 2 will not require chain rule. Okay, so hopefully you pause the video and wrote those in the appropriate place. This one will not require chain rule. It would require quotient rule. Also, this one will not require chain rule. It would just require the power rule. So these are the two that you're going to write on the left-hand side of your tree map. So we have y equals the square root of 3x minus x to the 5th. And then we have secant x all to the 4th power. So taking the derivative here, well, you know already how to take the derivative of the outer function. So the outer function here is just this like square root x. So that's the first thing we're going to take the derivative of. And the derivative of square root x is 1 over 2 root x. But our inner function is not an x, so we have 1 over 2 root, and then the derivative of the inside is 3x. And the inner function does not change. Now we take the derivative of the inside function. So we're ready to go in and take this guy's derivative. So the derivative of the inside is 3 minus 5x to the 4th. You must have parentheses around this quantity because that entire quantity is multiplied by this rational expression that we wrote down first. Okay, so actually that derivative we just took, if you want to think about it as like a formula for the derivative of square root of u, and we'll put this on a formula chart soon. I'll give you a formula chart soon. So if we have the derivative of the square root of u, where u is a function other than just an x, the derivative of that is going to be 1 over 2 root u, that inner function remains unchanged, times du dx, the derivative of u with respect to x. Next one requires chain rule here, secant x to the 4th, because we have an outer function and an inner function. So I'm going to take the derivative of the outer function first, which is that 4th power there. So taking the derivative of that 4th power, oops, I forgot a prime here on the last problem. The 4 comes to the front, and I have a new power of 3. And then the inner function, secant x, remains unchanged. So I took the derivative of that 4, the outer function, and now I'm going to take the derivative of the inner function. The derivative of secant is secant x times tangent x. So all of that is the derivative of secant x to the 4th power. You could simplify, you could move this secant over here with these and make it secant x to the 4th, but you don't need to. Okay, last ones. Sort those. 3 of them require chain rule, 3 do not. Okay, so hopefully you pause your video. Pause if you need more time. Okay, this one does not require chain rule. Neither does this, and neither does this. This one's just power rule. So I was running out of room on the bottom of my tree map. So let's just take the derivative of these here. So the derivative of ln x cubed plus 5x. So we're going to first put 1 over the inside function because the derivative of ln x is 1 over x. And now we multiply by the derivative of the inside, so we get 3x squared plus 5. Differentiate the outer function first, which is the ln, and then differentiate the inside. So that's our answer. You need parentheses around the second quantity, or you could rewrite it with that second quantity in the numerator. So kind of our formula, if we are taking the derivative of ln of u, it's going to be 1 over u times du dx. 1 over the argument times the derivative of the argument. Okay, the top one here, a y equals e to the 11x to the 4th. So to take the derivative of this, we take the derivative of e first, e to a power. The derivative of e to a power is e to that power times the derivative of the power. So now we differentiate the inner function, and this is our inner function. We get 44x cubed. Okay, so if, again, when we put that on our formula chart, if we have the derivative of e to the u, some function other than x, that derivative is going to be e to the u times du dx. e to the power times the derivative of the power. Lastly, we have a function inside of a function. So when we differentiate this, we're going to do the power rule first with this 8th power. So we're going to have 8 and then our quantity raised to the 7th power. The inner function does not change. And lastly, we multiply by the derivative of the inside, 6x plus 5. And again, you must have parentheses around that quantity. When you're doing any of your rules, chain rule, product rule, quotient rule, and you have a quantity that's more like a binomial or trinomial, it has more than one term, you need to have parentheses around that quantity.